Just 6 months ago, I was under impression that Gaussian Splats are dead end. Cool looking, but it was useless for real games, and the use case was extremely narrow. But then I see this example, a fully playable FPS in your browser. The whole environment built from scans which converted into 3D splats. And look at this one, or look at this example. One image, Claude Code, 5 minutes, and you get 3D world. You can walk inside, and there are even objects that you can move around and they collide with the environment. So did something change in past 6 months? Yes, it is, and I'm gonna walk you through to the all changes in 3D.js landscape. We're gonna see what new tools or approaches released, how we can bring 3D splats into the game, and whether it actually makes sense, or everything that I mentioned is just another fancy demo. And before we continue, I want to give credits to Gabriele Romagnoli, who helped me to figure out the landscape of 3D.js. He's also a tech ambassador, like diving into the 3D.js, provided me with plenty of insights. His links will be in the description. Steph here, guys. Let's talk about 3D Gaussian Splats, also known as 3D.js. Alright, so it's been a while I was not looking into this, and I'm gonna confess, there are quite a lot of things happening, so my attention was grabbed by this awesome demo from World Labs. Basically, there's a guy named Nielsen Corner Software, I hope I pronounced it right, and he built a tool called ImageBlaster, which is essentially a Claude Code skill with some scripts, which does an amazing thing, right? It actually takes two APIs such as World Lab and Full AI and build up the environments using all the tools available right now. So it built up the splat environment, create a collider, and create objects inside. And from the demo, it looks sick. It's like, what? And it looks very good, and you can run it in the browser and you can export it into Unreal Engine, Unity. From what I saw before, it's completely different. And I also did a test, so wait a bit, I'm gonna show you how it works on my end. And at the same time, I also see quite a lot of news that there are more and more supports announced for 3D.js, such as Query Engine updated like 3D.js to Mesh, which build up like quite nice meshes right now. And the quality there improved significantly. Then we see the plugins for Unreal Engine that supports Nanite system. Wow, I mean, well, that's impressive. Marble, World Labs also dominating the space. Then there was a hackathon featuring World Labs, and there was like people like developing some stuff. We do have this FPS shooter. Well, there's quite a lot of happening, right? So it seems that we finally touching the grounds with the real use case, right? We're gonna go over all of them now, but first let me quickly remind you what are splats, right? So the splats basically is like a tiny ellipsoids representing position, color, opacity, and shape. I saw some crazy guys even added like the material properties, but that's not the usual case, right? So it's like a small blob of paint in some position in the space. You also can have opacity, and that's it pretty much. And there's millions of such stuff representing like some area. So it's completely different approach from triangles, right? And of course, this is more of a static capture rather than editing, right? It's way more difficult to manipulate such entities or like captures, but it's possible, but again, less practicable. And when it all started, again, there's a relatively new technology. It became popular around 2023, right? It's just 3 years. Polygonal 3D exists for, I don't know, 30 years, 40 years already. And before, it was a problem that there is no collision, right? So it's just like splats and they do not represent any collision. So that was a problem. It was very heavy to render. There was unclear how to do LODs, how to do segmentation, and pretty much use cases was just to view them. And almost all the problems started to be addressed this year. Again, Query Engine introduced Mesh to 3D.js version 3, which is so-called mesh inclusive. That gives you a splat together with the mesh. That helps a lot to build the collision, right? Marble also did the export in GLB, also building up the collision. We got Nano.js plugin for Unreal that actually adds up Nanite style LOD for splats and allow render them way more efficiently at bigger scale, which is absolutely amazing. We do have SPZ format that makes files 10 times smaller, so like the weight becomes smaller, easier to work with it. And we already had Spark.js, that's a Tree.js library to render that in web, but GLTF, KHR actually building native support, and as we know, it already become a release candidate, so I guess it will be very soon. And for the SPZ, right, before like one apartment scan could wait like half gigabytes, right now it decreased to 5080, which is amazing. Okay, so I give it a test to just make sure it really works, right? So I cloned the ImageBlast. It was very simple. Again, essentially that's like skill with some application that will run the generation, so you can preview that on the browser. So pretty much simple stuff. I just cloned it into the folder, open Cloud Code there, and just said like, hey bro, can you install it, right? And it was almost instantly. It's quite simple. There's not much to install. The only thing you need to do if you want to try it out, so there is .n.example file which shows World Labs API key and full app key. So you have to create your key, of course, for full and for World Labs. For World Labs, it is in platform.worldlabs.ai. On full AI, just go full.ai keys or something. Of course, the project is open source and free, but you pay for the credits. I cannot say they are expensive, so the one world generation with bunch of object might cost you like $1 or something, depending also like how much objects you will use. And full AI is used to create additional objects using Hunyuan 3D. Okay, so what's the process? I actually set the ends. So here's my chat. I set the environments. I added the image, which will be this image. And here's what happened. So it run all the stuff, and then he asked me like, what objects do you want? I just said like, okay, just give me like 5 biggest objects. I didn't want it to wait to test it fast. And after a while, it just give me a link to the viewer. So we can go to the viewer right now, and after a while, here we go. Here's the result, and this is really cool, right? It's exactly like promised in the demo, right? So here's the space, right? I can walk. I can go through because the collision here is not set, but they're not lying, like there are mesh wireframe. So you can go to this mode and you can see like what it generated. Of course, not perfect one, right? Well, it is like, it only renders like what you see from the image. You can watch it like this as well. Yeah, there are objects that actually interacts with the collision, which is, I mean, this is super fun. This is really interesting. Yeah, I can imagine some use cases now, right? I mean, it was so difficult to achieve this state before, like, just don't get me wrong. And since this is a real mesh, etc., you can really drop it to Unity, Unreal Engine, or build up something on the web. So as mentioned, under the hood, there's World Lab model, which is absolutely the GOAT right now. There are other alternatives, of course. We're gonna take a look on them later, but I think this is the biggest guys who do this splats in, like, we call generative splats, right? So like there are two way generally, like you can scan and transform that, capture data into 3D GS, or you can generate it. And these guys actually focus on generation, and it looks actually quite sick, right? And we can expect even more from them. The most recent update was in April 2, the Marble version 1.1 with auto expand worlds, I guess like adjusted pricing. And there's extremely big hype about World Labs, and they recently closed a huge 1 billion rounds with 200 millions from Autodesk alone. And there's also like big bakers such as AMD, Nvidia, Fidelity. This is actually serious, and big guys really believe in this technology. One of the things they also was doing is that it now exports colliders in OBJ FBX format, which is actually closing this gap. And I saw quite crazy examples. And of course, that's a showcase example, sponsored or developed by Marble itself. But that's really cool. Like, I mean, there's whole locations, and I mean, this is actually happening. This is starting to make sense and starting to look nice sometimes. But we're gonna see more awesome examples. So Marble is not alone here. We also do have Hunyuan with Hunyuan Worlds, which a few weeks ago they released Hunyuan World 2.0, which is also a similar thing, right? They do have quite a lot of stylization, as I understand, and they also produce 3D geometry on top of that. And it is actually open source. From tests, seems that Marble is still better, smoother, but what they show is also impressive. I was testing it, like, it looks quite good. Another deviation from this would be probably generating them as a streamed video. And one of the biggest example will be a Genie tree, which is available only on Ultra Plan or something like that, but it can generate the words. It can actually play, right? But that's like a streamlined generation. And Genie is not alone, like there's a whole bunch of things happening around this, but it's like way less controllable. And I know, like, I wasn't hearing anything about it like for a while already. It was some hype in the moment, and now seems like there is not much of a use case. Quite interesting project from former Pixar developers called Odyssey 2 Max, which is about like the world model understanding. They also do export sort of like 3D-GS. There's like a sort of like different purpose, the simulation of real world, but also very impressive. Now, the improvement in the quality is not only reason why it become popular, is also because, again, we do have more tools to actually work with it. Here are Nano.js for Unreal Engine that actually makes it possible to render extremely more efficient. Then there is even like Splat render from Design that allows to render 4D GS. That's basically a splat sequence. It's not really a big use case for it. It's more of a VFX and really is used only in VFX and in very rare cases in Unreal Engine. For Unity, we do have Unity Gaussian Splatting by Eras-P. For 3GS and VR, we still have SparkGS, which is absolutely amazing. It's built by World Labs. It supports PlySPZ Splat, pretty much all formats, including SOG, which is streamed splats. We're going to talk about it later, and I'm going to show you an amazing example that I was showing in the intro. Just stick with me for a while. And of course, Curie Engine and Marble exporting like GLB is very huge, because now we can actually operate with it, like collide with it. That's starting to make sense. There was also a hackathon called Sense AI, where there was like more than 30 developers actually focusing on building something with splats. And I was actually talking with these guys, extremely passionate, awesome guys. And they also introduced an open source toolkit called Sense AI World Model Kit that has kit for all three platforms, such as WebXR, such as Unity, and such as Unreal, allowing basically to speed up process significantly. Well, that guy was actually serious. You can now build up the collider, actually extract the splat from the video right in one place, and this is more than amazing. You can easily find all these tools in the internet. I'm gonna try to put it on Top 3D.ai as a one article with all the useful links for you to explore. Now, when we were talking about Marble, that was about generative splats. What about scans? And there's one more cool example from Play Canvas team. So these guys actually double down on splats, and they are only one that doing like that much effort in terms of like engine developers to support splats. So it all started with this demo, like the FPS shooter in the environment that completely built from splats. All what you see look extremely nice. It looks quite realistic because that's a captured scanned data. That's also a huge work of an artist called Christopher Schindler. That's quite of effort doing like all this scanning, but it was brought into the game and it runs on the web. You can go and try it out. How cool is that? That is really fascinating. And they basically explain all the process behind. So what made it possible that Play Canvas actually has a platform called SuperSplat, where there's like a lot of people can publish it, and some of them are actually open source. So it was built on top of like one location. Another thing is that Play Canvas actually introduced Splat Transform, which is an open source library with the CLI that allows to process the splats into a variety of formats and make it optimized for web. There is like SPZ, as I mentioned, like to compress it, or for example, SOG, which is used in that demo. SOG is sort of like super compressed format ready for streaming that works in some way as LOD, allowing to run extremely big splats without heavy memory consumption, which we actually see in the demo. The whole process and what tools they use, they explain on their website, and all tools, again, are open source or free. And there's also SuperSplat website where you can explore splats, which most of them are scans, and I would say I am quite impressed. Some examples I saw here are like indeed impressive. There is also a SuperSplat editor here, which allow to actually set the collision right here, and like they are very, very fun to explore, right? The quality is extremely improved, right? And the fact I can run it like on my PC just almost instantly, I think that says something, right? That's absolutely cool. So if you ever wanted to explore splats and work with them, this open source CLI is must have. It's absolutely amazing, open so much opportunities. And to explore Splat, there's SuperSplat website. There's also Scaniverse from Niantic with 50k plus scans, which is also insane. You can explore that. And there's also Polycam. And now we're coming to one more topic. What about if you want to create 3D GS, which actually might happen? So with Marble, Hunyan works like with generative, it's clear, which is generated from prompts or image. For the capturing, we have plenty of options. Let me give you like the best 3 tools I figured out. So it's Scaniverse by Niantic, and it's completely free on device, supports iOS and Android. Probably the best tool to start with. Then there is like most hyped one is Curie Engine, I guess, with the recent updates with producing the mesh. Pretty much works with video capture data, scanner data, or LiDAR data. Or there are specialized scanners that you can buy specifically for splats capturing, or like point cloud capturing. There's also Polycam, but it's a paid one. It supports LiDAR and produces very, very good quality. Also because on iPhones, it relies like on best capturing options. For Windows users, there's like free beta version called PostShot, and same local open source called GS Splat. Well, actually, I tested that a while ago, and that's a quite convenient tool from Nerve Studio. If your GPU is 4+ GB, you already can try to run that. So plenty of options to start with, including the free one, which is absolutely amazing. But what about the capability to run the splats? And again, here we also have huge increase. So as I mentioned, like you can now start to produce GS splats, like they call it like training splats. Like GS Splat now starts with 4 GB VRAM. That's way less than it was before. As we see on SuperSplats, you can write big heavy splats on mobile devices even, because thanks to like this new formats, the optimization, like streamed format, I mean really like you can run it like 60 FPS on the phone, which is huge progress, right? Before, not every splat can be run like that. Also thanks to this year Niantic SPZ4 format makes files 10 times smaller and the compression 5 times faster. Additional bonus to accessibility, and the main reason why we're actually talking about it is because we do have more use cases. And I'm same as you guys, I see something, I believe in it, right? I go and check like whether it's possible, because yeah, it lacks of use cases and now they're popping up, and that's great. I think technology by itself is really nice. If the quality will improve, if it will be optimized and stuff, which we see happening right now, there will be quite a lot of use cases, and perhaps we'll see new genres, like as you can capture like real building and develop your game around that. How cool is that? I don't know, guys. Let me know what you think in the description. That was Steph. Like and subscribe, and see you in the next one.